Hey guys, Mr. Milton here. Today we're going to talk about systems of inequalities. At the end of this video, you should be able to find all solutions to a system of inequalities by graphing. Okay, so a solution to any equation or inequality is an ordered pair or any ordered pair that makes the equation, inequality, or system true. Okay, this doesn't change with systems either. Okay, so a solution to a system of equations is found at the intersection of the two lines. Okay, as we've done earlier in this chapter when we had equations, that's where they met, which is the only place, which is why there's only one solution. Okay, so basically when we graphed our two lines, if we're just doing a system of equations, all of our solutions have to happen on the line. So where they met was our solution. Okay, a solution to a system of inequalities is found in a region of the graph, or an area, created by two lines, which is why there are infinitely many solutions. Okay. So, how many regions were created when we had one linear inequality? So yesterday when we graphed a linear inequality, say it looked like this, we shaded one side, notice that there's another side, there's always two regions created. Okay? How many regions will typically be created when we have two linear inequalities? That answer is 4. Typically there will be 4 regions created. Okay, 2 regions per line. Okay, and how many of those regions represent the solutions to the systems of inequalities? The answer will be 1. Okay, we'll look at that as we go through these examples at the bottom of the page. So, let's look. So nothing really changes of what we need to do outside of the fact that we need to do 2 inequalities on the same graph. Okay, so we have y is less than 1/2 x. This is in slope-intercept form. It's nice. Our y-intercept is 0, so that's where I'll start. 1/2 is our slope, so up 1 over 2, up 1 over 2, up 1 over 2, go down over. And I will, just so you can see this line all the way through the graph. It is important to have your lines go through the graph. I know that with systems of equations, a lot of people will get in the bad habit of going to the point that they see a intersection and stop. Here, we have a whole region that we need to make sure that we find out where the boundaries are. So that's what we need to make sure that we go through the graph. Okay, it says y is less than, so it's not or equal to, so our line is dotted, dashed. So I want to make sure we dot this line so we can see it. Alright. And less than means that we will shade below the line. Okay, and so because I know that I'm doing another line, I'm going to really shade kind of lightly. Okay, not doing a whole lot because I don't want to interfere with the next line there. Okay, so I can see where my shading was, and I'm going to do that before I start my next line. My next line, more for your benefit, but if you have different color markers or pencils or something like that, that might be helpful, is x is greater than or equal to 1. Okay, remember x equals, we have our lines like that, and then x is, I have to put a point everywhere that x is 1. There's a lot of them here. So this is a vertical line. Okay, greater than or equal to, that is a solid line. Going through here, so solid line. Okay. And now I usually say to shade above or below, but this is a vertical line, so we can't shade above or below. X is greater than, we had to go towards numbers that are greater than 1, and that's going to be to this side, so we'll shade on this side of our line. Okay. And so you'll notice that I shaded on this side of the line here, and there's just one region where we have both blue and red shade. Okay, and in that region, that's where our solution is. So you can shade that darker if you like, or you can see that that's the solution just based off of those colors. Okay, so it says give two solutions to this system. So there are a couple solutions. Well, there are more than a couple, but we'll give a couple solutions. One of them, 6, 0. Okay, all the way over here. 1, 2, 3, 4, 5, 6, 0. Where's that 7, 0? Okay. Another one, 3, negative 5. I mean, we have a lot of points that we can use. 1, 2, 3, 1, 2, 3, 4, 5. Okay. So any point in that area. Okay. So looking back here, just want to make sure that we see how this plays into what we said earlier. We have 4 regions that were created. 1 here, not shaded at all. 2 here, shaded in blue. 3 here, shaded in just red. And then our 4th region in here, shaded in, I should write it over here, shaded in red and blue. Okay, so we have 4 regions that were created. Only one of them, this 4th one, is the solution. All right, I'm going to leave it to you to graph and find the solutions for this second system of inequalities. Make sure you do that. To the back side, let's look at some more examples. Okay, so we have 3x plus 4y is greater than or equal to 8, or negative 8, and 6x minus 8y is greater than or equal to negative 16. Okay, I'm going to change these to slope-intercept form, so I'm going to try to get y by itself. So I'll start by subtracting 3x from both sides. So I'll have 4y is greater than or equal to negative 3x minus 8. Divide by 4. And I get y is greater than or equal to negative 3/4 x minus 2. So minus 2, my y-intercept. My slope is negative 3/4, so down 3 over 1, 2, 3, 4. I can go up 3 and to the left, 1, 2, 3, 4. Okay, this is a solid line. Okay, so because it's or equal to, it's a solid line, we will use a straight edge. Okay, and try to make a straight line through there. All right. So that's our first line there. All right, we have to do the same thing with our next line. Put it into slope-intercept form. I'm going to use red here. So again, getting y by itself, I have negative 8y is greater than or equal to negative 6x minus 16. Then I'll divide by negative 8 on both sides. Remember, in an inequality, because we divided by a negative number, our signs will flip. So negative divided by negative is positive. That'll simplify to 3/4 x plus 2. So my y-intercept is at 2. My slope is 3/4, so I could go up 3, 1, 2, 3, and to the right, 1, 2, 3, 4. I could go down 3, 1, 2, 3, and to the left, 1, 2, 3, 4. This is also a solid line because our sign is or equal to. So I'll use my straight edge again. Okay, to try to make the solid line through here. All right. I didn't shade the first line. Okay, we'll have to go back and worry about shading. So now let's worry about shading. Glad I used 2 different colors and I can tell these lines apart. That is a reason that you want to do that first, especially if you're just using one color pencil. But going back to shading this first line, I said y is greater than this line, so that means we should shade above it. I'm going to shade above. Again, I don't have to do a whole lot of shading. I do want to see the regions that are part of my solution for the blue line. For the red line, it's less than, so I'm shading below. Again, Don't need to do a whole lot of shading, but I do need to see what parts are part of the solution for my red line. Okay, and so you should notice that this section here, above the blue line, below the red line, is part of the solution, or is the solution, the region where the solution will work. So now it says, is 5, -2 a solution? Well, let's see. Going over 1, 2, 3, 4, 5, -2 is the solution. Yes, yes, it is the solution. All right. Okay, looking at, try to shift this over so we can see it all. The last example here. Last example here says solve the following system of inequalities and then answer the questions that follow. So we have y is greater than 3/2 x plus 4, already in slope-intercept form. That's nice. 1, 2, 3, 4. Slope is 3/2, so up 3 over 2, or down 3 left 2, down 3 left 2, down 3 left 2. Okay. It is greater than, so it is a a dotted line, because it's not or equal to. So dotted line, dotted line, dotted line, all the way through there. Great. Okay. And it's greater than, so we're shading above the line. I don't want to forget to shade twice in a row. Okay. All right. Second line is not in slope-intercept form, so I want to get it there. I want to subtract 6x from both sides. -4y is greater than -6x plus 8 divided by -4. And so I get y is greater than 3/2 x minus 2. Okay, again, negative divided by negative. Oops, we divided by a negative. Need to make sure I flip my sign. Okay. So, negative divided by negative becomes positive. Positive divided by negative becomes negative. Y is less than 3/2 x minus 2. So my y-intercept is at -2. My slope is 3/2, so I can go up 3 over 2, up 3 over 2, up 3 over 2, or down 3, left 2, down. Okay. So, and then this is a dotted line as well because it's less than. Okay. And less than means that we will shade below. Okay, now you'll notice that as we shade below here, we shaded above the first line. How many regions were created in this problem? 1, 2, 3. Only 3 regions. Why? Because we have parallel lines. Parallel lines, and that means they never intersect. Okay, they never intersected. Okay, so how many of those regions represented the solutions? The answer is none. We don't have any regions where there were shading colors of both places. Okay, is this always the case? No, this is not always the case. Okay, in fact, if our problem were changed only slightly, where we had y is, let's say, less than 3/2 x plus 4, and 6x minus 4y was less than 8, then we would have actually this same line. Oops, sorry. We would have the same lines here, dotted here. We would have dotted here. Okay. And we would have shaded below for the blue and above for the red. So just because they're parallel does not mean that there's no solution. Okay? But because we have parallel lines, it did change how many regions we had. Okay? So there we have it, systems of inequalities. They're very similar to just linear inequalities, except doing both at the same time. You do have to make sure that you're organized and you're thinking through being neat enough so you can think about what you have written. Okay? All right, that's that. See ya.